This is sections 8.3 and 8.4 of Honors Algebra 2, dividing polynomials. So recall from first semester that a polynomial is an expression that can be written as complex numbers times a variable to decreasing powers. For example, 4x to the fifth minus radical 3x cubed plus 2/5 x squared minus ix plus 10 is a polynomial. Very complicated polynomial because it has coefficients that are irrational numbers like the radical 3, a fraction like 2/5, a complex number like I. But that's a polynomial. Anything of that form where it's the same variable to decreasing powers multiplied by complex numbers, real or imaginary, is a polynomial. So we know how to add, subtract, and multiply polynomials. Now we're going to learn how to divide them. And there are two methods. The first one, which will always work for any polynomials that we're dividing, is called polynomial long division. And it uses essentially the same process as the long division you would have done back in elementary school. So remember how to do long division of numbers. If we have 873 divided by 14, we write the 873 underneath the division sign and a 14 outside. We take the 14, it doesn't divide into 8, so we look for how many times 14 divides into 87, and it goes in 6 times. Then we write the 6 on the top, above the 7, and then take 6 times 14, that gives us 84. We write that underneath the 87, we subtract. 87 minus 84 is 3. We bring down the next 3, and we divide 14 into 33. Well, 14 goes into 33 2 times, because 2 times 14 is 28. We subtract 33 minus 28 and we get 5. Now 14 doesn't go into 5. And we've brought down all the numbers we can bring down. Now we could bring down decimals and we could keep going, or we could declare this equal to 62 plus 5 over 14, or the mixed number 62 and 5/14. So it would be a quotient of 62 with a remainder of 5, the number you're left with all the way at the bottom. That's the same idea that we're going to use in dividing polynomials. So, for example, let's divide x cubed minus 5x squared plus 4x minus 2 by the polynomial x minus 2. We write the top one underneath the quotient symbol, x cubed minus 5x squared plus 4x minus 2. We write the bottom one outside. That's what we're dividing by. So that's the dividend underneath the quotient symbol and the divisor out front. And here's the process. We take the highest power term that's underneath, which is x cubed, and we divide it by the highest power term that's outside, x. So we're going to take x cubed divided by x. Okay, well, x cubed divided by x is just x squared. We cancel one of those x's out of the x cubed. So we write x squared above the x cubed term, because that's what we divided. We take what we just wrote on top, the x squared, and we multiply it by the divisor, x minus 2, and we write that underneath. So x squared times x minus 2 gives us x cubed minus 2x squared. Then we subtract, and we put the whole thing in parentheses so that we distribute the negative. X cubed minus x squared, because our x cubed minus x cubed is 0. Negative 5x squared minus negative 2x squared is negative 5x squared plus 2x squared, which is negative 3x squared. You have to be careful with the division, with the negative signs. Alright, we bring down the next term, the 4x. And I take the highest power term underneath, which is negative 3x squared, and I divide it by the highest power term outside, which is x. So I divide negative 3x squared by x, and I get negative 3x. So I write that on the top, minus 3x. I take what I just wrote on top, the minus 3x, multiply it by x minus 2, and write it down below. That's negative 3x squared. Negative 3x times negative 2 is positive 6x. Then I subtract, putting that in parentheses. Negative 3x squared minus negative 3x squared is 0. 4x minus 6x is negative 2x. I bring down that minus 2. I divide negative 2x by the x that's out front, I get negative 2, so I write minus 2 up top. I take minus 2, I multiply it by x minus 2, and I write it down below. So negative 2x plus 4. I subtract. Negative 2x minus negative 2x is 0. Negative 2 minus 4 is negative 6. And now x minus 2 won't divide into negative 6 because I'm out of x's. So that's my remainder. So here's the way I write my answer. I write it as x squared minus 3x minus 2. That's the quotient. That's what I have on the top of the division sign. Plus the remainder, negative 6, divided by what I was dividing by, x minus 2. So the quotient plus the remainder over the divisor, what you're dividing by. So that's your final answer. So it's a quotient of x squared minus 3x minus 2 with a remainder of negative 6. Here's another example. 3x to the fourth minus 9a squared x squared plus 4a to the fourth minus 2ax cubed, all divided by ax minus 2a squared plus 3x squared. Now when we do this, we're going to write it in the right order. And the right order is with decreasing degree of the same variable. So our variable, if we take x to be our first variable, we're going to write this as decreasing powers of x. So 3x to the fourth would be the first one. We'll then take the term that has an x cubed, so that's the negative 2ax cubed. Then I'll take the term that has an x squared, which is the negative 9a squared x squared. The next term should have an x to the first, but I don't have a term that has an x to the first, or a term with an a cubed. So I have to put it in there as a 0 a cubed x to the first, or 0 a cubed x. So if I'm missing a certain power of the variable, I need to throw it in there and hold its place with 0 times that. So notice the powers of x are decreasing as I go from left to right, and the powers of a are increasing as I go from left to right. So this needs to have an a cubed, because I just had an a squared. And then the last term is the term that doesn't have any x's at all, but has an a to the fourth, so 4a to the fourth. On the outside, I do the same thing. I write it in decreasing powers of x. So 3x squared plus ax minus 2a squared. Okay, this looks very complicated, but it's the same process as the problem we just did. We take the highest powered term underneath, which is 3x to the fourth, and every time I'm going to be dividing by the highest powered term outside, which is 3x squared. So each time I'm always going to be dividing by 3x squared. Right, 3x to the fourth divided by 3x squared. The 3's cancel. 2 of the x's cancel, and I have x squared left. I write x squared on the top. What I just wrote on the top, I multiply by what's outside, and I write it underneath. So x squared times 3x squared is 3x to the fourth. Plus x squared times ax is ax cubed. Minus 2a squared x squared. So notice the terms I write below are always like terms with the terms directly above them. They always have the same variables. So I'm going to subtract, and I can do that because they're like terms. These first terms should always cancel. If they don't, I've done something wrong in my division. So 3x to the fourth minus 3x to the fourth is 0. That's good. Negative 2ax cubed minus ax cubed is negative 3ax cubed. Negative 9a squared x squared minus a negative 2a squared x squared becomes plus 2. So it's just negative 7a squared x squared. Again, these are like terms. I'm just adding and subtracting the numbers in front. Bring down the next term, plus 0a cubed x. And take the highest powered term underneath, negative 3ax cubed. I divide it by the highest powered term outside, which is 3x squared. I have a negative, the 3's cancel. I have an a and an x. So negative ax, I write up top. I multiply that by what's outside. Negative 3ax cubed minus a squared x squared plus, because it's a negative times a negative, 2a cubed x. I subtract. First terms cancel. Negative 7a squared x squared minus a negative a squared x squared is plus 1, so that's negative 6a squared x squared. 0 a cubed x minus 2a cubed x leaves me with negative 2a cubed x. So there you see why I had to hold the place with the 0, or I'm subtracting negative 2a cubed x from nothing. So now I take the highest power term underneath, negative 6a squared x squared, divide it by 3x squared. Okay, negative 2a squared. The x's cancel, so I write negative 2a squared on the top. I multiply by negative 2a squared and I write it underneath. So negative 6a squared x squared minus 2a cubed x plus, because I've got a negative times a negative, 4a to the fourth. And I forgot to bring down the 4a to the fourth, so let me do that as well. I subtract. First terms cancel. Second terms, I've got negative 2a cubed x minus a negative 2a cubed x becomes negative 2a cubed x plus 2a cubed x. Those are the same. They cancel. 4a to the fourth minus 4a to the fourth also cancel. So I've got 0. It means I have a remainder of 0. This divides perfectly into the dividend. So my answer is just the quotient then. X squared minus ax minus 2a squared. There's no remainder. There's a remainder of 0. So I don't need to include that. And that's my answer. Method number 2. Unlike polynomial long division, this does not always work. This is called synthetic division. And it only works when I'm dividing by a first degree binomial. So a binomial means it only has 2 terms, and first degree means the power of the variable is only 1. It's not anything higher. So for example, 2x cubed minus 10x squared plus 9x plus 15 divided by x minus 3. I'm dividing by a first degree binomial, so I can do what's called synthetic division. And this is the way I do it. I'm dividing just the coefficients. So I take the coefficients of the top, 2, negative 10, 9, and 15, and I write them across like that with a little bit of a space in between them. I skip a line, and I draw a horizontal line, and then in the top left I'm going to write the number I'm dividing by, which is a 3. The 3 is the number I'm subtracting off from x. So if it was x minus 3, I'm dividing by 3. If it was x plus 3, I'd be dividing by negative 3. Okay, so it's the opposite sign of that. All right? I bring down the first term, so I just bring down the 2 and write it there. I then take the 3 and I multiply it by the 2. So 3 times the 2 gets me 6, and I write it there underneath the negative 10. I then add negative 10 plus 6 gets me negative 4. Take the 3 times the negative 4, it's negative 12, and I write it underneath the 9. I add 9 plus negative 12, and I get negative 3. I take the 3 times the negative 3, I get negative 9, and I write it underneath the 15. I add, and I get 6. And then I'm done. The last term, the last number there, is always my remainder. It could end up being 0. And that means my remainder is 0. The other terms, the 2, the negative 4, and the negative 3, those become the coefficients of my quotient. And they match up with starting with one lower power than what I have on the top. So that was a 2x cubed. One less than that is an x squared, so this is a 2x squared. You always start with one less power. Then I've got minus 4x, then minus 3 by itself. So I'm just assigning them the proper powers of x, starting with one lower than what I was dividing into. So my answer is 2x squared minus 4x minus 3 plus a remainder of 6 divided by x minus 3. So it's a lot faster as long as you get the hang of it and how it works. Let me do another example. X to the fourth minus 2x cubed plus 13x minus 6 divided by x plus 2. So my coefficient of x to the fourth is 1, and a negative 2. Notice I don't have an x squared term, so I need to put a placeholder in of 0, because this is really plus 0x squared. So I need to hold the place for that one. Plus 13, so 13, and then negative 6. I am dividing by a negative 2, so that goes over here on the side in the little box thing, and I draw a horizontal line down there, skipping a line so I can write my numbers there. Okay, I bring down the first term, the 1. Multiply that by the negative 2 and write it there. Add. Negative 2 plus negative 2 is negative 4. Multiply that by negative 2 and write it here, so positive 8. Add. 0 plus 8 is 8. Multiply by negative 2. Get negative 16. Add. 3 plus negative 16 is negative 3. Multiply. Get positive 6. Add. Get 0. 0 is my remainder. My quotient then, I had x to the 4th at the start, so this is x cubed. 1x cubed, or just x cubed, minus 4x squared plus 8x minus 3, with a remainder of 0. So that's just my answer, is that quotient right there. So very fast, if you know how it works. Divide 6x cubed plus 7x squared plus x plus 1 by 2x plus 3. So I have got 6, 7, 1, and 1, because this is really 1x. Now what am I dividing by? This time it's a 2x plus 3 instead of just x plus 3. So I actually need to treat this 2x plus 3 as 2 times x plus 3 over 2. I need to factor out a 2. So I'll be dividing by x plus 3 over 2, but I need to account for that 2. So I'm actually going to write my answer as 1/2 of whatever I get. Because I'm also dividing by 2, so I can take care of that at the end by dividing everything by 2. Okay, so really I'm going to divide by x plus 3 over 2 first, then divide by the 2 at the end. Okay, that's my thought process. So if I'm dividing by x plus 3 over 2, I'm really, in my synthetic division, dividing by negative 3 over 2. Okay, draw my horizontal line. Bring down the first number, that's a 6. I multiply it by negative 3 over 2. 6 times negative 3 over 2 is negative 9. Write it there. Add, get negative 2. Multiply, I'll get positive 3. Add, I get 4. Multiply, I get negative 6. Add, I get negative 5. That's my remainder. My quotient then is 6x squared minus 2x plus 4. The remainder of negative 5. So plus negative 5 divided by 2x, divided by x plus 3 over 2 for right now. Now I'm not done, because I still need to divide by the 2 that I had factored out earlier. So I'm going to divide everything by 2, or multiply everything by 1/2. Okay? That means I'm going to divide each of those coefficients by 2. So that'll be 3x squared minus x plus 2. And then plus a negative 5 divided by, and I'm multiplying by 1/2, so that 2 is being multiplied into the bottom of that fraction. That just becomes 2x plus 3, which is what I had started with. Okay? If you don't get that, stare at it. Maybe you'll get it then. And that's your answer. Alright, your immediate practice problems are easier than that one that we just did. Divide. The first one you're going to have to use polynomial long division. The second one you can use synthetic division, so that's what I would recommend. Show all of your work, and that is the end of sections 8.3 and 8.4.